In this video, I'll show you how to repair an ASL brand oven if it's not heating. We have an ASL brand oven, model AF23, and right now it has stopped heating. Now let's check how it behaves. When the power is turned on, the power light doesn't come on. There are no signs of operation. Let's disassemble the unit and see what the problem is. First of all, we need to remove the control unit. To do this, we use a flat screwdriver to meticulously and with utmost precision and care and attention to detail pry up this block from the top, and with utmost care and precision carefully remove it from its mounting. After that, we bend the sides of this board and gently slide it upwards. Now we can take out the mechanism as a whole. Using a multimeter, let's check the functionality of the upper and lower heating elements. Let's carefully and securely connect the probes to the terminals of the heating elements, ensuring they are properly attached. The upper heating element is working. Here we have some mineral wool. We just need to slightly move it a bit to access the wire connectors. Here at the bottom is the second heating element. Let's thoroughly examine its functionality. As we can clearly observe, the heating element is functioning properly and efficiently. The multimeter, which is a crucial tool in this process, indicates that the electrical circuit is completely intact and operational. We'll be looking for the problem on the control board. Using a multimeter, let's check the voltage on the supply wires from the power circuit. Let's turn it on. Plug it into the outlet and check. Here are the power supply wires, the brown and blue wires. The voltage is 220 volts, which means the voltage from the power supply wire is coming here. We'll keep looking for the problem. After that, we'll use a multimeter to check the integrity of these contacts. Here is the very bottom switch. It is responsible for turning on the upper and lower heating elements. And there's a bit of charring on the plates, so I'll check the resistance between the wire and this contact that closes the circuit. I'm connecting one end of the probe to the power supply wire at the bottom and the other end to the contacts at the top. As you can clearly see, there is indeed a circuit at the very base of the contact, which is quite evident. But interestingly enough, there isn't one at the contact itself. Surprisingly, the circuit is broken. This way you can see. So, there's a specifically problematic issue between this pressure plate, which is connected to the wire, and also with regard to the plate that turns these contacts on and off for controlling purposes of heating elements. First of all, I'm going to carefully remove this handle. Here, I need to take off the spring from the bottom part, and then the handle will come off. I'll put the spring back in its place later. Let's begin by examining the spring, which is a crucial part of our mechanism. We need to ensure that it is in perfect condition before proceeding. Once we have thoroughly checked the spring, we will carefully place it back into its original position. It is essential that the spring stands upright and stable, just like this. After securing the spring, our next task is to remove the switch. This requires us to press the clamps gently yet firmly, allowing us to detach the switch without causing any damage. This step must be done with precision and care to ensure everything functions correctly. Here it is, removed. Now it will be easier to work with it. We disconnect the contacts, not forgetting to label the leads so that they don't get mixed up later. We carefully disconnect all the wires from the switch by gently pressing the lock that is on the connectors, ensuring no damage to the components occurs, and securely. To improve the contact between this pressure and the plate, I'm going to slightly and carefully bend this plate with a small hammer and try to gently solder this plate to the contacts with some solder, ensuring we don't have a high contact resistance. This will be done with precision and accuracy, ensuring optimal contact resistance is minimized. After that, we'll check the contact resistance between the plate and the contact. As you can see, there's almost no contact resistance, but I will also solder these contacts again, just to make sure we don't have this problem in the future. I'll clean off the oxides using a lubricant similar to WD-40, as it works well for removing oxides. But I'll also solder these contacts again, just to make sure we don't have this problem in the future. I'll clean off the oxides using a lubricant similar to WD-40, as it works well for removing oxides. In this process, using a relatively small file, we will also thoroughly clean the contacts at the junction to avoid heating and high transition resistance and ensure optimal performance. Very gently, carefully. To effectively minimize any potential damage to the protective coating, it is essential to implement specific preventative measures. These measures are crucial in stopping the materials from undergoing further oxidation, which can lead to significant deterioration over time. The protective coating acts as a vital barrier, safeguarding the underlying material from harmful environmental factors. By preventing oxidation, we ensure the material's longevity and durability, maintaining its integrity and functionality for an extended period. Then, using soldering flux, we'll clean these connectors well and solder them together. I'm going to carefully drop a small amount of phosphoric acid onto the contacts to thoroughly remove the excess oxidation that appears here when the metal is heated. Then we'll rinse off the acid with water thoroughly and completely to ensure that all residues are removed and to maintain the integrity of the metal surface, preventing further oxidation of the metal, and we'll solder the contacts using tin. After that, we'll check the contact resistance between the contacts and the plate once more. It's become minimal over time in many ways and aspects. So, we can rinse off the acid residues and put everything back in its place. Here are the remnants of the HLT Autopost washed away. All that's left is to dry it and install it back in place. To make it easier to rotate this handle, I'll apply technical grease to these protrusions. This grease helps reduce friction, ensuring smoother and more efficient movement. By carefully applying it to each protrusion, we enhance the handle's functionality and longevity. This will make it much easier to rotate.
To install the switch securely, we first align it with the designated slot. Carefully, we press it into place, listening for a click or feeling a snap, which confirms it is locked. This ensures the switch is stable and prevents accidental dislodging or malfunction, guaranteeing reliable operation.
We carefully and securely install the handle on the other side, with precision and attention to detail. I lightly greased it to make it easier to fit in. And we connect all of the various different connectors to this switch, as you might remember. And after that, we very carefully and precisely mount the entire control board exactly in its correct position with utmost precision and care. We securely insert these tabs into the groove on both sides, pull them down, bend them slightly, and secure them on both sides. Great care. Now we need to check how the oven works. We turn on both heating elements and timer simultaneously at the same time. The light bulb has turned on. Power is essential for the operation of the oven. Now, we just have to wait patiently for the oven to heat up to the desired temperature and then turn off automatically. The timer mechanism has started functioning, which accurately measures the oven's operating time. Let's open the oven and check the condition of the heating elements. They should be hot. Hot, both the bottom and the top. So the oven is working in mode